Example 1 in Stat 101 Examples Class 4 is looking at Venn diagrams. Our example is of university students. Considering a sample of 40 students, defining event A as the students taking Stat 101, those are in the circle A. Event B, the students taking Biology 101, those are in the circle labeled B, that's the red circle. And then event C, the students taking Math 101. Those are all the students inside that black circle being outlined. Total sample 40 students. First question, considering the simple event A, find the probability that a randomly chosen student takes Stat 101. Probability of A, all the students that fall within the shaded circle A, the circle shaded in blue. Total number of students we have inside that circle, 1 plus 5 plus 10 plus 12. Out of our possible 40 students, remember we had 40 students in total. So the probability are the number of outcomes we're interested in, that's 28 students out of a possible 40 students, giving a probability of event A of 0.70. Considering the simple event C, find the probability that a randomly chosen student takes Math 101. Probability of C, the probability that a randomly chosen student takes Math 101. All the students that fall within the circle labelled C. So how many students are there in total inside that circle? Number of ones we're interested in are the 10 plus 12 plus 6 plus 2 divided by our possible outcomes are 40 students in our sample, giving a probability this time of 30 divided by 40 or 0.75. Moving on to joint events, considering the joint event A union C, find the probability a randomly chosen student takes Stat 101 or Math 101. A union C, remember, so they can take Stat 101 or they can take Math 101. So shading here, they can fall inside the circle A, they can fall inside the circle C, or indeed in the overlap between the two. So considering this joint event, how many students have we got inside our total shaded area? Can do this two ways, by adding up all the values inside the shaded circles and dividing by our 40 as we've done before, or remembering that we've got 40 students in total, so we could just take the 4 students in biology that don't take the other subjects and take this away. So 40 take away 4 should give us the same result, leaving 36 students out of a possible 40, so our probability is 36 divided by 40, 0.9. Remember, we can leave those probabilities as fractions or decimals. The next example, considering the joint event A intersection C this time, find the probability a randomly chosen student takes Math 101 and Stat 101, the two subjects at the same time. To find these students, these will be in the intersection of the two circles, the Math circle and the Stat circle, the area being shaded in blue. The 10 students added together to 12 students are the ones we're interested in for this particular problem. Total of 22 students out of our sample of 40, giving a probability for the joint event A intersection C of 0.55. Considering the joint event A intersection B intersection C, find the probability a randomly chosen student takes all 3 papers. So they need to take A, they also need to take B, and they also need to take C. These are the students we will find in the overlap of the 3 circles, these 12 students we're highlighting. So our probability is our 12 students we're interested in divided by those 40 students in our sample, giving us a probability of 0.3. Moving on to another joint event, A intersection B intersection C dash, C complement. Find the probability that a randomly chosen student takes Stat 101 and Biology 101, but not Math 101. It's the complement of C, C dash, C bar. It's the complement of C, so not Math 101. So looking at our Venn diagram, which students are we interested in? So they're going to be in the overlap of the A and the B circle, but not in the C circle. So the ones we're interested in are the 5 that are left in that triangular shaped area, the overlap between A and B, but not C. So our probability of A intersection B intersection C complement are 5 out of a possible 40. Probability of 0.125. And that's the end of example 1.